Thank you for coming today. We have a great webinar for you. We're going to talk about how to build enterprise chatbot architectures. My name is Gad. I'm the host for today. I'm coming to you from TensorOps. We're a small boutique company doing mostly generative AI consulting and professional services. Today with me is Diogo, who is our one of our principal engineers. How are you, Diogo?
I'm good, and I'm happy to be here.
And Yaniv from this really small company called Microsoft that nobody heard of, right?
Thank you very much, Gad. It's a pleasure to discuss with you about these challenges, and really hope we will have a vivid discussion.
Yeah, we're super excited to hear from your experience and the cases that you see there at Microsoft. I'm sure it's like really broad and really interesting for this audience. So we said we're going to talk to you about chatbots, but let's see how we're actually going to roll this webinar. So basically, we're going to ask, why did chatbots become so interesting and popular recently? What makes them interesting as a use case? And then what do you actually need to have a chatbot, right? So what are the components that make it a good chatbot? And then we're going to talk about the difference between LLMs and LLM applications, more specifically GPT versus ChatGPT. But the most interesting part is going to be when we start to deep dive into, okay, how do I move from a PoC chatbot, which is really easy to build, to something that is enterprise grade, right? Accurate, stable, secure, all of these features that you really care about once you move from, a demo app that you do in a university course, or within a month that you run it internally, or to that like real valuable business applications that we will see through this webinar. And then we're going to see some more advanced tools. So besides the chat experience, you can also develop stuff like assistants, code interpreters. So we're going to look into a code interpreter architectures, and we're going to talk in the end about how do you fine tune these LLMs. So what are the three pillars of optimizing LLM applications? So maybe just to start, Diogo, you've been in this industry, I mean, for at least 13 years of doing machine learning and data science. Chatbots are not new, right?
No, they are not, and they have been around for ages, but no one really wanted to use them. And the problem was that they were not giving you the answers that you want most of the times. And people just want to get answers fast, and they don't even want to use search boxes, and even using Google takes training to do well. So people don't want to talk. You just want answers.
So, there is a very classic use case that everybody uses when they want to show why you need a chatbot, and that's going and asking questions over knowledge bases. So take the most complicated knowledge base in the world, probably, which is flights, right? It is so difficult to know how to cancel a flight, how to get a refund. The data is scattered around so many components of the application. So when you want to get a question like, how do I cancel my flight and get a refund? Why would a chat be better than just search? Because you've been in search, you help build search applications in Farfetch, for example, in your past. Why is search not good enough, even if you have a wonderful chat search experience?
Yeah, the problem is mostly humans as well, because we are not very good at synthesizing information or extracting information from a large amount of results. So you want the answer, like, how can I cancel my flight? And you just need a straight answer. You don't need to read through all the documentation around the politics of canceling flights and the law and so on. So that's one of the issues. And the other is there's information changing all the time, and the systems, they need to be finely tuned to get you the best results as fast as possible.
So I like what you're saying, because search effectively gives you a reference to the document, right? It will find where's the document that has the answer that you need if the search system worked well, but it doesn't give you the answer. What happens if your answer is scattered across multiple documents, or what happens if you just want to extract a very synthetic small part of your existing document. So yeah, chat experience could be wonderful because you can collect data from the user and then just bring them the right answer. You don't have to like send them off to like these multiple documents.
Exactly.
And then, like, it's amazing to see that this article is more than 1 year old. It looks like it's been forever since OpenAI released this. Diego, are we getting closer to AGI?
The answer, like, we are getting closer for sure.
Yeah.
Like, I remember with my colleagues when we saw a ChatGPT application, and we've been training neural networks for a long time, and we were not like really believing of what we were seeing. So there was a lot of hype around it, and still is. And like AGI is a bit far away, but there's a lot of like experts that says that is around the corner, and we'll not see it coming. It's not going to be a straight day that, okay, now we have AGI and yesterday we didn't have. Like, it's something that is going to be evolving in a very continuous manner.
Yaniv, I think that for me, I've been in, I came originally from a cloud background. Microsoft was one of the players, but since ChatGPT came, the spotlight really came to you. Do you see cases of large success with chat applications, ChatGPT on Azure, or generally in industry?
Yeah, and I fully agree with Diogo. We are moving really fast towards AGI. There's an interesting talk between Jan LeCun and Lex Friedman. Really encourage you podcast to hear it. Yeah, so I think in terms of there's an interesting research by Menlo Ventures. They backed Pinecone and Databricks and some other great companies. And I think that the biggest barrier for AI adoption is proven ROI. And this was published like 2 weeks ago, and I think this is a super interesting use case by Klarna, where they show the metrics of the business value, save like 40 million with their customer experience, with their organizational chatbot, improve the customer experience. So I think we are in a tipping point where we moving fast, and there is a clear value for the business.
Okay, so Diogo, you've been building chatbots in the past year for several customers at TensorOps. Walk me through, what does a chatbot need, right? So what are the components that a chatbot has? You are muted, I think.
Yeah, classic. So the first part we need to get right is the chat interface and the conversational aspect of it. Like, it has been around for ages, so it's very easy to make a conversation-like interface these days. But then you need intelligence capabilities, like understanding actually the conversation that's going on, and allow the user to get answers by question answering and so on, and routing and getting information and general information. It needs access to tools, because like if you want to cancel a flight, ideally the chatbot would cancel it for you straight away. And then it comes the contextual knowledge. So the chatbot on KLM would need exactly the laws that are applied to KLM and the politics, the policies, because you don't want to happen the same thing that happened to Air Canada, where the chat gave a wrong answer about the refund. And then optional, of course, conversational aspects with voice, text to speech, and vice versa, to create a more human like experience.
So again, if I'm taking us 5 years back, and you had tools like Dialogflow to build chatbots, and they could provide you with its chat experience, and then like the concept of intent and understanding the intent of the user, what would you say improved in the past year?
Yeah, the biggest change, I think everyone here on the audience knows, and that's why they are here, it's the intelligence capabilities. Like, the breakthrough with chat interface and chat applications was the LLMs. Without the LLMs, there would be no ChatGPT, or without the GPT behind it, there will be no ChatGPT. And the bigger, the better. That's the question about these LLMs. It's not necessarily true, but up until the time that we decided as scientists to go as big as possible, we didn't know that, okay, like a huge model will not overfit to my problem. It will actually be able to answer in many different problems in a very accurate way, like summarization, question answering.
It's a nice observation, because I think in somebody's mentioning like chatbot, sorry. So I know, like in CatBoost, for example, or XGBoost, these are models that as the bigger they get, the more tend they are to do overfitting. And in LLMs, actually, the bigger they get, the more they become more intelligent. They don't just do their work better, they actually invent new capabilities. So if a small model can do language understanding, a bigger model can do better language understanding, but it can also do general knowledge or question answering or arithmetics. So you're adding capabilities as the LLM.
Yeah, and maybe like it's still up to check. Maybe it's just overfitting to all these type of problems, but it's overfitting in a good way, because you can actually have the general model working.
Right. So now let's ask ourselves, what is the difference between ChatGPT and GPT? This is a question that very often confuses our customers, and we're still in the very early stages of this webinar, so we're talking about the basic stuff. Yaniv, why isn't ChatGPT and GPT the same?
Oh, so this is a great question, and I think this is the difference between a model, a foundation model, and an end-to-end application. So GPT is a foundation model, but usually you will not use it as is in order to serve your customer, because you need to build on top of it to connect it to your business logic, guardrails, content filter. And I really like to use the example of strawberry versus strawberry cake. So you can eat strawberry, but most of the people like, and you can eat strawberry, but maybe it's not mature enough, or maybe it's not sweet. But usually you're going to a restaurant and you're not ordering a strawberry. You are buying or ordering a strawberry cake. So the strawberry in this case is the GPT, and the strawberry cake is the ChatGPT. This is the application. You can use the strawberry to build amazing things for your companies. And to some extent, simply put, this is the difference between foundation model and end-to-end application.
I see. So I love this. I love this example of the strawberry cake, which is like you can use these strawberries to create something that is bigger. It can be a chat application, but in many other ways, it can be like another application, right? Like, so ChatGPT is just yet another application on top of GPT, but somehow it became the like, the king of this era of LLMs and LLM applications. Let's start with the most basic one. Before we get into like production grade stuff, how would you go ahead and build a simple chat application on top of Azure? Yaniv, how do I get started with Azure? So I want to get GPT on Azure. How do I do that?
So 3 simple steps. The first one is create a subscription, an account. The second, you need, similar to the OpenAI experience, you need an endpoint, an API key, and that's it. Just choose different deployment. Deployment can be either a small GPT, GPT 3.5 with a smaller context, or GPT-4 Turbo. Deploy it, and then you can run it. And I think that there are different experience, and everyone can use it. So you can use the no-code experience if you are not, if you prefer to use and you don't like have a development background. So you can use the no-code, where you can, try different prompts, A/B testing, playing with the temperature and different parameters, and then run experiment. And then once you have like a great prompt, you can, take it to the dev team. And for developers, so we have the SDK, and great thing with the no-code experience, so you can copy the code. So you can build something with no code, copy the code to a notebook or any other option, and then run it as a code.
I do want to say to the people in this webinar, if you do have questions, you can definitely put them in the webinar. Also in the Q&A, we'll be happy to address your questions through this webinar. It's really going to be helpful for us to focus what you're saying. And we even have Gabriel, who joined as a panelist, you'll be able to like answer some of your questions. So if you do want to ask some stuff, do let us know. Going back to that topic, so Azure, you can get, so this is something I kind of like missed out on, by the way, what you're saying. There is the Azure OpenAI Studio, which is a very similar experience to ChatGPT. So if you want, for example, to get an enterprise-grade ChatGPT, you can definitely do it within Azure. There is great benefit to doing that. And then, like you're saying, you've done some of your experimentation. You should always remember that it's an API. You can always interact with the API from your application wherever you're hosting it. One thing that people are very concerned about when they're choosing a platform is, am I going to be vendor locked, right? So Azure has a partnership with OpenAI. Does it mean that when I'm choosing Azure, I'm locked to OpenAI?
So we as developers really like the concept of freedom of choice, and I think Microsoft implemented really nicely. So you have like 1,400 different models where you can choose either OpenAI, which they have like, and we have like amazing partnership with OpenAI. But if you would like to test like and deploy other models like Llama, smaller models, or a mixture of experts, and even Microsoft, I guess most of you are not familiar with it, but Microsoft do have open source foundation model with great performance. Only we call it SLM, small language model, fee 2 billion. And again, it's fully open source. So you can choose either the managed experience with OpenAI and to some extent more mature, and you can use any of those open source models or any other providers of LLM.
Basically, I can bring my own model. I can use an open source, and of course, I'm getting access, an exclusive access these days to ChatGPT or GPT, which is what most developers eventually go to. If to be honest, like I wish all the best to all the others developing their own LLMs. It's great to see competitions, but we do see people going after the GPT because of accuracy. So besides that, it's worth mentioning maybe that Microsoft is like it. When you're building on top of Azure, you have many more features than just an LLM application. You have translators and ML ops and LLM ops applications, right?
So again, the example of the strawberry cake. So you would like to build strawberry cake. So you need different services, need different components. So maybe you need a text to speech for the chat experience, or a speech text, or any other type. Or if you would like to connect to your chat application knowledge base, RAG, retrieval augmented generation. So you can connect all of these dots in order to build amazing, and you can choose whatever you want. You can take an external vector database, other open sources. You don't have to use all of these components, but this is the experience. And again, in order to build or to bake an amazing strawberry cake, LLM is not enough, so you need other services as well.
Okay, I will say we're getting a few questions here. One is a person struggling with a throughput of OpenAI on top of Azure, saying it's slower than going directly to OpenAI. How can you address throughput? We do have it in the future, further down the webinar, but you want to throw maybe a word about PTUs?
Yeah, so due to the unprecedented demand, okay, there's a huge demand for this deployment, and the pay-as-you-go. So there are two different options. The first one is pay-as-you-go, and it's a shared resource. So based on the shared resource, you should expect higher latency, and we are trying, to build new clusters of compute. But if you would like to take it to enterprise, there's another concept or a different way to consume it. PTU, it's a provision throughput unit, where on some tests you can reduce the latency by 4, 5, or 6x. So if you are working on a POC, use the pay-as-you-go and save money. If you would like to upgrade from POC to production, please consult with your Microsoft account manager or specialist, and the offer is provisioned through per unit, again, mostly for enterprise-grade applications.
I will also say TensorOps is working closely with Microsoft on these cases. So if you want to come to us for consulting and analysis of your LLM application, you're most welcome to do that. We'll have the link sent to everybody who registered. I think, Yaniv, your question also addresses the next question that we're having is, all these open source models are great because they're open source, but you actually have to put in a virtual machine to host them. And then, once you're doing pay as you go, you can go low as like $1, $2 just to test your application. You don't have to start with a baseline of a machine with a GPU that amounts to at least a few thousands of dollars a month. So I think it kind of gives you the intuition of how you can work with this. We had a great webinar about breaking down the cost of LLM applications. You can check it out on our YouTube. Yeah, very often you would like to start with a pay-as-you-go model, whether it's Anthropic or ChatGPT or whatever model that is hosted that you can just pay for the tokens that you use. And then once you scale up your application, you may find that it's cheaper to host a Llama, but that really depends on the volumes. And there's multiple ways you can do that. And you've mentioned that. We'll get down to that further in the webinar. So Diogo, as a person who has built LLM applications, what is the most basic example of a chat architecture that you know?
Yeah, so the most basic, and probably some of you in the audience already built something like that, is to have Streamlit as your front end and a back end powered by LangChain. However, it's a good idea to start with containerizing your front end and your back end in terms of standalone APIs. So then you can actually take the POC to production in a much faster way. You can also connect directly to LLM third parties like OpenAI, but you can also use Azure OpenAI, which will give you more flexibility and less vendor locking.
I see. So, Streamlit as a web framework to build a chat interface, they actually have a good template for building chats, great to start with. And then a backend using LangChain, going to Azure. Yaniv, would you call that an enterprise-grade application?
So I heard from many customers that LangChain is an amazing tool, but to some extent, it's really hard to manage all of the components of it. And, there are various types of challenges, session management, connecting a memory component, hallucinations, and as you mentioned, the content filtering. So we have a nice example with an interesting company from France, and building guardrails on top of it. Again, if you are running a simple POC, it's great, but if you would like to take it to production, it can really hurt your company's or enterprise reputation.
Yeah, I'm thinking about session management. So, this architecture, as great as it is, I find it difficult to rely on that because a lot of, I'm chatting with an assistant and then I'm doing something else, and then I have to go back. And so this is very an online architecture. There is no sense of persistence of the chat and a retrieval of the session. All of that does not exist. Also, I'm seeing people asking about RAG. Yeah, there is no context awareness. And I do want to give an example, Diogo, I think you have it in the next slide, about hallucinations and guardrails. So here's an example of what happens when you don't fine-tune your system. I'm not saying LLM fine-tuning, but more fine-tuning of your system. So what happened there?
Yeah, so there's an urgent to deliver products, and everyone wants to ship their chat application to the customers as fast as possible without even testing it, or not really heavily testing it. And this is a good example that's someone with very no effort at all allowed to break the DPD chatbot, which is like a transportation company, And the chat was just answering how to write Poland and so on. And that's that's basically lack of guardrails and content filtering, and definitely not an enterprise grade solution, whether it was written or built on top of LangChain or not. Like there was a lot of components missing in this chat.
So Yaniv, so one of the questions that I'm always getting is why should I go to Azure? And I think in Azure there is a less of a chance that it would happen. Is there some kind of guardrails that you add additionally to chat or to GPT on top of what you're getting from OpenAI itself?
So I think that the most interesting, and Microsoft are, I think, an important customer of OpenAI. So OpenAI powers the great products that like GitHub Copilot and the Copilot concept with the Office and the Outlook. And I think to some extent you are getting an enterprise grade application with the challenges we're hearing from customers that they prefer to work with Microsoft because it's compliance, SOC, HIPAA, and other data. Your data is your data. We are not using data is stored encrypted in your Azure subscription. It's not going out to for a travel. So this is what I'm hearing from customers about why they prefer to work on top of Azure.
Because yeah, like when, for example, I had to build a chatbot application for a medical use case, I wanted like to know that my application is HIPAA compliant, and I could find that within Azure, which I could not yet find in OpenAI, at least to the best of my knowledge. Okay, another form of like lack of customization. So if you're using LangChain, did you know that you're actually using a prompt for the chat? So like Yaniv said, GPT is just a model. If you want to use a chat experience, you actually have to provide a chat application, and some of the chat application is within itself another API call or another LLM call. When you're using LangChain, this is actually what you're getting, right?
Yeah, this is for keeping the memory, the prompt compact. You have like a very basic chat, a prompt that actually just takes the user context and the history to summarize it for using in the chat conversation.
You know what I like about it? So you built your first LLM application using LangChain, OpenAI. Great. You think there is no place for customization because what you did was so simple. Actually, under the hood, you chose the way that your assistant is configured because like LangChain is saying here, you're an assistant to a human powered by a large language model trained by OpenAI. Who said I'm trained by OpenAI? Maybe I'm trained by the LLM is actually Azure. Who said it's just an assistant? Maybe it's an assistant for scheduling calls. Maybe I should introduce already. So like, it's very easy to use these frameworks, but you really have to understand how you tune them. Want to talk about how you actually define good prompts? Like this is again an example where you just took a prompt out of the box. It's not necessarily the best one, and then you're getting these mistakes like happen.
Yeah. So there are many techniques, to optimize the performance and, responsible AI. So to name a few, hallucination-free response. So use only things that you are familiar with and you can read here the text, and, tone safety. Don't use like strange jokes or any other different techniques. Obviously jailbreaks, there are the bad guys, the red teams that are trying to unlock the system prompt. So you can read here the text, but I think there's a different structures, and you can use this structure to make your application user friendly and more responsible.
Okay, so moving past the the most basic architecture, in the previous one we introduced like a LangChain backend. What happens when I change my backend from LangChain to Assistance API?
So
Do
yeah.
What is, Diego, maybe I should ask before, what is Assistance API?
Yeah, Assistance API was something that OpenAI just released in the last dev conference. You can use it directly on Azure, and the great thing about using Azure, if it's the case of like your application, is the compliance with GDPR and HIPAA in some of the locations, and that's very important for many industries. The good thing of Assistance as well is that some of the issues that we're talking about, like guardrailing, session management, function calling, code interpreter, memory, and so on, and even RAG, you can have it off the shelf directly there. Of course, that everything has a price, and the price here would be to be more vendor locked into Azure OpenAI, especially the OpenAI Assistance API.
I see. Okay. So, we've seen the most simple use case. I want to take a jump and start to speak about advanced use cases. One thing that we are really seeing customers trying to implement is code interpreters. So maybe to just give the sense of what is a code interpreter.
Yeah, so
yeah, go ahead. Sorry.
No, like LLMs don't run code, and they don't know arithmetic. They predict the next token.
What do you mean? You see on the left, I'm asking a question, I'm getting an answer. Is this answer not correct?
It seems correct, but if you make the calculation, is approximately. And this type of calculation should be deterministic and absolutely accurate.
So LLMs cannot run code. Why is that?
They are basically neural networks, transformers models based on transformers that are trained to predict the next token or the token that is missing in a context of a sentence. So it may sound smart enough when it explains you the calculation, but it's not doing the math. Sorry.
Okay, and so they're good for text, right? So they're good in like predicting text, and text can be code, so they can predict a perfectly good running Python code, even better than some of the developers I met in my life.
Exactly.
What can I do with it? How can I leverage that?
So the way it's being used, and that's what code interpreter is like translating a user prompt or a user conversation into Python code. And the OpenAI models and the Llama code, they were trained on top of a lot of examples of code. So as you said, like it writes code fairly well, better than a lot of developers. And you can leverage that to make function calling, which is a capability of LLMs that will decide whether to call a tool or not. And in the OpenAI is function calling, but in the open source is instruct models. Yeah.
So what you're basically adding up here is some kind of tuning for the LLM application to know that it needs to run code, like you're giving it access to tools. And then you're also adding a Python executor. So effectively, all you're doing is you're taking the output of the LLM, which is code that you wrote, and then you're passing it to something that is completely not AI, right? It's just like a container that runs code. It's whatever.
Exactly. It's just like it could be a Python command line.
And then you run the code and you get the results. The result is again text, right? Text or images, and then you embed them in the chat experience.
Exactly. And the LLM will see the result of writing a particular piece of code. And if it gives an error, the LLM will see the trace back, for example, of that error, and it will act upon it. If you build the agent correctly, it will act upon it, and it will try to do a next iteration. Yeah.
And is this something you can do with LangChain?
Yes, like the part of like the basic example you can do with LangChain, but then the part of making a sandbox where you have like absolute safety Python environment to execute code, it's not.
Okay, and then like what you're getting is like this kind of result, right?
Exactly. So
yeah,
so you can here see what happened under the hood. So in the first thing that the LM said was, okay, I'll write Python code, which is basically the calculation that you did, and execute it in the Python environment. and then it got the answer, which was not approximately.
Yeah. Okay. Yaniv, many people are not aware of that, but besides, like, if I want to, besides like writing arithmetics, once you can write code, you can also write code that does data analysis. We're seeing this use case quite often. A code interpreter being used for like processing large databases or large data sets. So you're asking questions like, what's the average in my data set? That's basically the same architecture. What is TaskWeaver?
So TaskWeaver is an open source by Microsoft, and it's a code-first agent where you can run different tasks of data analysts. And it's really complicated. So the first step, you need to plan and build the plan, and this is one of the challenges of planning, one of the challenges of LLM. And then you can generate plan. Okay, so I have like a different task to run, and then for each task, I'm opening a few new subtasks, and you can use the code generator. So it generates the code for you, visualize, and work and back and forth, and then generate a response where the user can run. Back in the days when you had to build a Python script with different SQL queries, and TaskWeaver is just one example of this open source.
So that's like,
So
that's like an automated like data scientist framework implemented. So it's a complete open source, right? It has nothing to do with Azure. You can deploy it on whatever platform. You can deploy it on your Mac, right, with your own Llama 2.
So this is the concept of agents where you have like a purpose-built agent. So in this case, the agent is like maybe data analyst or software engineer, and the performance of the purpose-built agents is much better than the general models. So you can take the foundation model, fine-tune it, and then use it with your use case.
Yeah, we're getting a question here. Is the LLM smart enough to match each subtask to the most appropriate LLM agent? That's part of the implementation. So part of it is defining the agent correctly. So the router agent correctly, so it would understand how to match. Does it always happen? Definitely LLMs has some hallucination. So I'm not sure but we did see this framework working quite well in production. I want to jump to say that many people don't know that, but Microsoft actually has a vast set of open source that they contribute to the community, right?
Yeah. So these are the open sources that power large products at scale, the Copilot products. So PromptFlow is, again, all of them are open source. PromptFlow is the building prompts and building flows, evaluate. I think this is one of the most, and I'm hearing a lot of customers talking about the challenge of evaluating, building, for instance, LLM as an evaluator. So they're using GPT 3.5 and GPT-4 as an evaluator. Semantic kernel is building different agents. LLM Lingua, some of the guys here ask to reduce the latency. So LLM Lingua, it's a prompt compression framework. TaskWeaver we mentioned. AutoGen, it's a multi-agent. So usually you need different agents and how they connect. And maybe this is the question that the JR asked here. So AutoGen, sorry, it's like multi-agent managing different agents. And the Phi2, as I mentioned, is the foundation, again, open source, SLM 2 billion. So this is the ecosystem of the open sources.
Quite amazing. Yeah, before starting to work closely with Microsoft, I was not aware of how vast the open source ecosystem is. We're moving towards the more advanced topics. So I wanted to speak about 3 pillars of LLM optimization. So you got your LLM application, you're using the assistance API, scale, you already have your secured Python environment for like doing the code interpretation. Results are still not good. How can you go and improve the performance of your application? So basically we're talking about 3, right? Prompt engineering, RAG, and fine-tuning. And let's talk about how we can introduce them in the context of chat. Yaniv, you mentioned already prompt flow. So we gave the example of how, in the LangChain, you're using a prompt out of the box. Now, let's say I want to take the prompt that LangChain uses out of the box. It's an open source, or I can override it and, start to fine-tune it to my own, fine-tune the prompt in order to my own requirements. How does prompt flow help me? What does it give me?
So it's kind of building different flows and connect the dots. So you have like different components and you need to connect the dots. So here you can see an example. And one important thing, so you can automate the process of building stuff and evaluating. So A/B testing. So you are building one prompt and then you would like to try a new prompt. And another best practice is that companies are running. So building a golden set is a set where you have like a question and answer, and then you can A/B test against this golden set, so you can evaluate. And this is a nice example. This is an evaluation platform, and you can check what is the performance of GPT 3.5 or GPT-4, changing the prompt, and it's automated. So it's like running manual processes or to automate it. And I think this is an important gap between building LLMs at scale.
Yeah, as an organizational leader or organization leader, so I need to provide my engineers tools to do this prompt optimization, and instead of sending them to like do it on their notebooks or without a structured way, this tool allows me to have processes in place in order to do the fine-tuning, which is quite great. Another question, which is kind of obvious. I built a chatbot. Let's assume I'm KLM and OpenAI did not train on my proprietary knowledge or something changed. I want to make the organization, the chatbot, or aware of the organizational knowledge. Diogo, what would be the solution for that?
Yeah, like the solution, or at least the first thing you should try is to use a RAG or implement a RAG. Of course, you could fine tune, and we'll deep dive on it later. And there's a lot of science around if I should or not fine tune the LLMs that I'm working with. But if you really want to use your LLM in a production grade environment to answer to the questions the users make with accurate results, then you have to go to RAG. And this is basically allowing the LLM to make search to your own database.
And why is RAG difficult? Like I know, I've heard from so many people saying RAG doesn't work. So why does this even come about?
Yeah, because RAG is search behind the scenes, and search is very difficult. And there are some people here on the audience that actually develop search systems. So you will know better than anyone how hard it is to create a good search system. And it can be built in many, many different ways. There are like infinite possibilities. And probably one of the most successful lately is hybrid search with dense retrieval, with embedding search, plus some sort of a keyword ranking algorithm, such as BM25 or other types of solutions, and then combining it to give you the result.
And I like that, in Microsoft, you actually have, in Azure, you actually have RAG as a service for some of the application. I'm not saying it's 100% fit for all the applications because it's very hard to tune, but for some applications, especially on top of limited data sets, you should definitely try out the Assistance API with RAG as a service.
Yeah, at least for the first check, try that. It's gonna
and
be
great. This one is where I wanted to go with. A lot of customers, were still here when you used to train your own model, and they're getting the LLM and they want to fine tune the model because they're used to that. Whenever you're getting a model, you actually have to do something to it, training, to fine tune. Would fine tuning help me in the case of lack of knowledge?
The answer is it would, but after one day or less than one day, that knowledge would be already outdated. And that's the same for every trained model. And that's the same for GPT. Like some versions are data up to 2020, 2021.
But from what I've seen, getting the LLM to know new stuff requires really training. And like, during the training, this is a very heavy process. The LLM is being tuned with a lot of information. What can happen? So like you're saying, Azure can support fine-tuning of LLMs. What would happen if I just pushed a lot of information through fine-tuning into the LLM?
So again, it's like then is a craft that is that is like you need to know what tools you are using, and if you are training the model with bad data, then the result's going to be bad. And this is the example, a very funny example of someone that trained fine-tuned the LLM. I think it was 3.5 model to answer to create posts in the same way that person speaks, and so that person took like hundreds of thousands of Slack messages, and then the result was that the LM or the assistant was always skipping the question and saying like for not writing the exact post.
So I think that when it comes to fine-tuning, it can really help you generate the kind of chat experience that you want, because it's like fine-tuning is like exposing or putting an emphasis of some of the LLM skills. So the LLM is a multiple skills model. It can do question answering and arithmetics and all this stuff. And the fine-tuning is like kind of like showing it what is the expected output for every input. It can actually make it forget a lot of its previous skills. So not necessarily using fine-tuning is the right thing. It's more about showing it examples of how you want it to behave in certain applications. And fine-tuning is considered a best practice now when you go to production. So it's great. It's a service that's available through Azure. What do I need in order to do fine-tuning?
Quality examples. That's it.
Quality examples. How
High
many?
quality.
So what would be like a number? Like if people would ask you like, I want to fine-tune GPT 3.5, for example, for writing a chatbot that would help me schedule meetings with in my clinic.
Yeah. So we've seen like above 100. You can use tens as well, tens of examples.
Wow.
You don't need, like back in the days when you trained an object detection, you need like 10,000. I trained YOLO V3 a few years ago. You need, I think, more than 10,000 examples. So you don't need thousands. I think with hundreds and maybe tens, you can get really amazing results.
I see. And it is kind of a costly experience, right? So you don't want to like do fine-tuning on a daily basis, right? It's something you do rarely when you go to production in critical phases of the application.
And I think there's an important for you guys, the audience. I had a conversation with one of our customers a few weeks ago, data science team lead, and they told me we'd like to fine tune. And I told them, great. Why? And they told me we would like to improve the performance of the model. And then I asked him, do you have like high quality? Did you start? And this is really important. You mentioned the 3 pillars. So it's a life cycle. You start with the prompt engineering. You can use and improve the performance with a few short examples. So you're giving the model a few examples. Then use the RAG. And then just then, when you have like a pretty good understanding of the world with some high quality examples, in order to avoid of the Slack 150K Slack messages and the hallucination. So this is the life cycle, and here you can see an example of I fine-tuned the model, again, really small one. I didn't use like many examples, so you can define what are the number of the epochs, learning rate, etc. And now only GPT 3.5 is available, but we are working on GPT-4 fine-tuning as well.
So 26 minutes and I have a fine-tuned model. It's more about the quality and planning ahead and not just, throwing data and seeing what you're getting, which is typically how you used to work with,
this is the last step after, you build the prompt, your prompt, add the few examples, and only when you have high quality examples.
And you need to be very good at evaluating your system as a whole, like you said, with the golden data set.
Mechanism, yeah. With golden
sometimes
set,
it's very overlooked, and that's the
yeah,
worst part.
exactly.
So, Diogo, coming to the end, there's multiple ways to build chatbots, and there is a lot of companies that offer you like chatbot frameworks. Come use mine. I wanted to speak about one that you recently developed for a company which does medical use cases. They actually sit in hospitals, very, very delicate information. You work with them on this use case. What can you tell me about it?
Yeah, so it was just released recently, and it's now being presented at a large conference in medical related topics. Like we built a code interpreter, like the sorts of Taskweaver, and we like the idea to collaborate, and it's crucial is to separate the responsibilities of like the chat interface and the backend of like where you are making the calls to the models and where you are executing the code. So we built like, this is a very simplistic representation, but basically we have the chat interface that complies with all the aspect of that company, and then the backend, which is the API that will run standalone. We'll have a LLM proxy, which is LM Studio, an open source by our company, that will actually allow no vendor lock-in. And the result is a chat interpreter. Yeah.
So this kind of thing, how much time would it take you from, I would say, POC to the first MVP in production?
So this project took us 2 months. And there are a lot of features that we want to implement that is not yet implemented. For example, the RAG part is still yet to.
I mean, like, don't spoil their surprise.
Yeah, exactly. But but it's like it was quite fast, and mostly because the ways we worked.
Right. So we came to this end of this webinar. People, if you have more questions other than the one that you already dropped in the chat, we'll be happy to address them. You can also ping us afterwards. We will send the recording to everybody who participated here. And also, you can search for TensorOps on YouTube. You will find us. This video is going to be available there. Again, thank you so much, Yaniv and Diogo, for participating in this one. And thank you, everybody who participated in this webinar.
Thank you, God.
Thank you.